Hello and welcome to Teaching Math. In this video, we're going to look at everything you need to know about solving multi-step equations. Here's what we will be solving today. Equations with variables on both sides, which is two-step equations. Equations where we need to combine like terms, equations that require the distributive property, and one tricky equation that has all of these steps combined. Let's get started. To solve multi-step equations, we use inverse operations to isolate the variables. And before we do that, we also have to take a look at, do we need to simplify the equations, meaning are they like terms that we need to combine, or is there a distributive property? So let's go ahead and move our variables to one side. We're going to use inverse operations and subtract x from both sides. Okay, 3x minus x will equal 2x. I'm going to rewrite the 5, and then x minus x will equal 0, and then we'll have to write the 17. Now let's move the 5 to the other side of the equal sign by subtraction. Okay, we're going to bring down the 2x. 5 minus 5 is 0. 17 minus 5 is 12. Now we have to divide by 2. Again, we're doing the inverse operation. What does this mean? It means 2 is multiplied by a number that will equal 12. So we're going to have to do inverse of multiplication, which will be division. Okay, let's go ahead and divide. 2 divided by 2 equals 1. 1 times x equals x. 12 divided by 2 equals 6. Here's our final answer. X equals 6. We can also put this inside the equation and to see if the answer is correct. Let's go ahead and do that. 3 times 6 plus 5 equals 6 plus 17. Well, 3 times 6 equals 18 plus 5 equals, what is 6 plus 17? That will be 23. Okay, 23 equals 23. And there you have it. Our answer is correct. Okay, for this example, we need to combine like terms before we start isolating our variable. So our like terms are 7n and n. So just one thing to remember is that when we're combining like terms, we want to make sure not to change the sign of the terms. And if it's positive, it stays positive. We do not use inverse operation here. We only use inverse operations when we're moving from one side to the other side of the equal sign. So we have 7n plus n, which will equal 8n. Let's go ahead and write that. So 8n minus 4 equals 28. Our next step is we're going to start by isolating our variable by using inverse operation. So our inverse operation will be adding 4 to both sides. Okay, 8n comes down. Negative 4 plus 4 equals 0. And 28 plus 4 will equal 32. Now we're going to divide. That means 8 is multiplied by a number that will equal 32. And what number could that be? To find that number, we have to divide, do the inverse operation. So then n equals 32 divided by 8 will equal 4. Here's our final answer. Again, you can go ahead and plug in your n to find if you got the answer right, and always make sure to check your answer. I'm going to move on to save some time. Okay, again, we're going to evaluate our equation, and we can clearly see there's a distributive property, which means 2 is multiplied by 1 and 2 is multiplied by negative 5k. And let's go ahead and distribute first. 2 times 1 minus 2 times 5k plus 4 equals negative 8. Okay, let's go ahead and multiply. So we have 2 times 1 is 2. Negative 2 times 5k, negative 10k, plus 4 equals negative 8. Now we have to take a look and see what else can we do to simplify. When I look over here, I can see that 4 and 2 are like terms, so I would like to add them. Combining like terms, both are positive. That means 2 plus 4 equals 6. We're going to rewrite the 10k, negative 8 as well. So now we are moving to subtracting 6, which will be an inverse operation to isolate our variable. Subtract 6 from both sides. 6 minus 6 equals 0. Negative 10k equals, well, 2 negatives. That means we have to add negative 8 minus 6 will be 14, and it will be a negative number, negative 14. Now we have to divide by negative 10. Okay, now let's simplify. Negative 10 divided by negative 10 will equal 1. 1 times k equals k. And then negative 14 divided by negative 10 will be positive 1.4. Here's our final answer. Let's go ahead and take a look at our last example. Again, we're going to evaluate what do we start with, how are we going to simplify it in order to use the inverse operations to isolate our variable. And here we have distribution and combining like terms. So let's go ahead and get started. First, let's do distribution, which will be negative 3 is multiplied by x. We're going to distribute, and negative 3 is multiplied by 2. Let's go ahead and rewrite everything else the same. Okay, let's multiply. Negative 3 times x is negative 3x. Negative 3 times 2 is negative 6. Let's go ahead and rewrite everything else the same. Now we're going to move to combining like terms. Please evaluate the equations. Where do you see like terms? Negative 9 and negative 3. So we're going to combine. Let's rewrite this side the same. Negative 9 minus 3 will equal negative 12 minus 5x. Okay, now we're at the point where we're going to use the inverse operation to isolate our variable. So that means we're going to add 5x to both sides. Just remember, you could have added 3x to the both sides as well. It doesn't matter which way you're taking your variable. Okay, negative 3x plus 5x will be 2x minus 6 equals negative 12. And then negative 5x plus 5x will equal 0. And now we're ready to add 6 to both sides. Okay, we're going to bring down the 2x. Negative 6 plus 6 equals 0. Negative 12 plus 6 will equal negative 6. Okay, our last step. Are you ready? We're going to divide both sides by 2. And our final answer will be -3. All right, let's summarize what we learned today. To solve multi-step equations, we use inverse operations to isolate the variable. But before we did that, some of the equations required to simplifying each side, which included distribution and combining like terms, and sometimes just combining like terms and just distribution. Then we have to move the variable to one side. It does not matter which side you move. I usually move to the left side, but sometimes I move to the right. Then we isolate the variable by moving our constant. Then we're solving our equation. If needed, we check our answer as well. Pat on your back, you've made it to the end. You've learned something new. If you like this video, please subscribe and watch out for our next video that has something to do with solution types. Remember, learning math takes patience, practice, and perseverance. See you next time.